Hi everyone. Our topic for this lecture series is all about couples. So I'll discuss equivalent couples, and in the subsequent slides we will solve uh, problems on couples. So we define a couple as a pair of equal forces oppositely directed whose effect is to purely rotate the body, the rigid body. So for instance, this is the rigid body and we have a pair of forces which are equal and oppositely directed, but they are not collinear in action. So it will cause the body to rotate in the following sense, which is counterclockwise. The distance, by the way, of the parallel forces, perpendicular distance, is d. So that's the effect. It will continue as long as the forces are not removed. Then this couple is equivalent to this one. Uh, This is the sense of the couple and the magnitude is F times D, and it is counterclockwise. You can place it at the center, you can place it at A, you can place it at B, you can place it anywhere. You can shift the couple anywhere on its plane. So you can place it there as long as the sense is maintained counterclockwise. So in other words, because the couple may be shifted to any point on its plane, let us prove that if you place the couple at any other point, the resultant couple or the effect, external effect remains the same. So at D, if the distance of D from A is x and it's the distance of D from B therefore would be D minus x. So if we sum up moment about D, the moment of F about D is counterclockwise. The moment of F acting at D about D is also counterclockwise, so we add the effect. Then if we have another point E, the distance of E from B is x. Therefore, the distance of the force at A from E is D plus x. So we have this statement, the couple is independent of its moment center. So it means that the couple is unchanged when it is placed anywhere on its uh, plane. So you can place it at any point on its plane. So to prove, let's have this first example. So moment about A, the couple is moment about A since the force at A is acting, the force acting at A has zero moment arm, so only the force at B will have moment about A. So it is equal to F times D, and the sense is counterclockwise. Then if we sum up moment about B, then the force acting at B will have no moment. Only the force at A will have moment about B, and the sense is still the same, counterclockwise, so F times D. Then if we have to compute moment about D, then it is Fx counterclockwise. Then the force at B will have also moment, F times D minus x counterclockwise. So adding Fx plus Fd minus Fx, so it will result to the same couple F times D, and the sense is counterclockwise. If we choose point E, then we make force at A, moment of the force at A positive about A because it is counterclockwise, and the force acting at B, the moment of the force acting at B about A is negative because it is clockwise. So it is F times D plus X minus Fx. So the result is still Fd and the sense is counterclockwise. So that is what we meant by a couple is independent of its moment center. Then I'll discuss next equivalent couples. Rotating the force of the couple while maintaining the sense then the couple remain unchanged. So that is, the forces of the couple may be horizontal and vertical distance is d. They may be horizontal as long as the distance is still, perpendicular distance is still d, or it may be inclined as long as the distance is d and the sense remains the same, and that is counterclockwise. So I hope you get that principle. Changing the magnitude of F and D while maintaining the product FD as well as the sense. So you can change the magnitude of the force into another magnitude at the same time the distance between them. So in this case, we have 1.5 F, 1.5 F, and the distance between them is 2/3 D. If you get the product, and the sense is the same, FT. Next, shifting the couple to any point on its plane. This is the principle here, which we already discussed. You can move the couple anywhere on its plane. So that's it there. Then shifting the couple to a parallel plane. So you have here the couple. Uh, Using the right thumb rule, the curling of your forefingers would be the direction or sense of the couple, and the magnitude is FD. You can move it above, you can move it or shift it to a parallel plane. Now it's on top. The same sense is shown, and so the effect is the same. Or you can make it, you can place it plane below the original plane, as long as the sense is the same. So that is what we meant by shifting the couple to its parallel plane. So this couple here is the same as this couple here, FD, and equal to transferring the couple to any other position or point on its plane. So that's the principle in the preliminary discussion in this part here. So I'll now discuss the general couple representation. This is for 3D, assuming this is the plane of the couple and this is the couple. We have F in that direction, then negative F here. They are oppositely directed. Then let we select a point. Let's say the moment center is A. So the moment of the force acting at B would be the position vector RAB cross the force. Remember? And this is the position vector AC. So the moment of the force about point A, the moment of this negative force F about point A would be the position vector RAC, then cross with the negative force. So that is RAB, position vector RAB, position vector RAC. So remember that from the first part of statics, the main diagonal of the parallelogram is simply the sum of these two vectors. So in this case, we have position vectors, then the length of this main diagonal is the position vector. I hope you remember that in our preceding lectures. Then the other diagonal is represented by the difference of these two vectors. In particular, it is equal to RAB minus RAC if the arrow is going down. So this is RAB minus RAC. Remember the other diagonal, because this is the negative of RAC. If you form again another parallelogram, the other is negative RAC, so it is parallel to this direction and down to the right. So it is parallel to that. So that is RAB minus RAC. So in this case, if these are the two position vectors, then the position vector between any point on the line of action of this couple, the forces, would be denoted by R. So for instance, that's R. Therefore, the moment about A due to the couple is equal to RAB cross F, then plus RAC cross the negative F. So if you factor out R, if you factor out F, then we have RAB cross quantity, or sorry, RAB, quantity RAB minus RAC cross F is equal to the moment about A, about point A. Since RAB minus RAC is R, the position vector between the forces of the couple, so therefore the moment of this couple is unaffected by, it's unaffected. So meaning to say, even if point A is here, below, or there, remember the principle that the couple is independent of its moment center. The result is still R cross F. This is defined as the moment about point A, or any point, any independent point between the two forces that are equal in magnitude but oppositely directed, known as the couple. So that's the principle. So any moment center, the magnitude and sense of the couple remains unchanged. So that's the principle. I hope you get that. So meaning to say, this system is equivalent to this couple here. The couple is acting at B. Then the couple is the same, R cross F. It may be at C. The sense is by right thumb rule. That's the sense. Then it may be represented by this couple here, which acts anywhere on the plane of the couple. Then it may also be this way. We have double arrow header. Then that's a couple. Your right thumb must be positioned in the direction of the double arrow. Then curl your forefingers. That's the sense of the couple. And then the couple is perpendicular to the plane of the forces of the couple. So remember that. Or lastly, this is the effect. So we have the couple here, and this is the effect or the sense of the couple in that direction. That would be the curling of your forefingers. So let's have this example. Show that the couple systems shown are equivalent. So what is the magnitude and sense of the resultant couple? So let's prove that the resultant couple for each case is the same. So 50 Newton forces constitute a couple, and their sense is clockwise, while the 30 Newton forces constitute another couple, but the sense is counterclockwise. So we anticipate that the net couple or the resultant couple is clockwise. So let's consider clockwise as positive. So the first couple, 50 times 6, then the second couple, minus 30 times 4. So again, let's evaluate. Couple in this part A here is 50 times 6, then minus 30 times 4. So since the net sign is positive, then the sense of the couple is clockwise, and it is equal to 180 Newton meter clockwise. In the second situation, we only have one couple, and the sense is clockwise, and the magnitude is 30 times 6. So 30 times 6 is 180. This is the same as the couple system at A, so that's why they are equal. Clockwise also. In the third situation, we have here a couple, 40 and 40. The sense is clockwise. So the magnitude is 40 times 6 clockwise, then plus 20 Newton meter, which is also clockwise. So 40 times 6 is 240 clockwise, plus 20 Newton meter clockwise. So that is 260 Newton meter clockwise. Then minus, because this is counterclockwise, minus 80. Remember that the couples are independent of their moment center. So we can place it at one point on the plane of the forces, then they can be combined. So the result is 180 Newton meter clockwise. So 40 times 6 to 40 plus 20 to 60 minus 80 is 180 Newton meter clockwise. For our second example, determine the resultant couple to each of the following couple system. So we have a 3D couple system here. That's the first, and this is the second. So for the first, we have to evaluate the moment about each axis. So moment about x. So we have uh, 60, 60 times 3, and that's positive. Then no more because this couples here is, this couples here is about the y-axis. And this is also about the y-axis. And the other force passes through the x-axis. So the moment about the x-axis is simply 60. This is positive. Same curling as your four fingers, your right hand towards the positive x-axis. So 60 times 3 is 180 Newton meter. Then moment about y. So this moment here, 90 Newton meter couple is the same, has the same sense as the positive moment about the y-axis. You curl your four fingers here, your right thumb towards the positive y-axis. So that's positive 90. Then this 50 Newton forces constitute a couple which is negative. So negative 50 times 6. So moment about y is 90 minus 50 times 6. So it is negative 210 Newton meter. Then moment about the z-axis, this is the positive sense. So these two couples are not involved because they are on the y-axis, about the y-axis. So since the positive sense is in this direction, so it is simply negative 60 times 6. So MAZ is negative 60 times 6. It's negative 360 Newton meter. Therefore, the couple system is equivalent to 180I minus 210J minus 360K Newton meter. For part B, we have moment about X is 80 times 3. And that's the only couple because this couple is about Z. This is also about Z. And this is about Y. So that's it. Then moment about Y, you position your right thumb. Curling of your four fingers will be in this sense. So it is 50 times 3 meters. So that's the moment about Y. 150 Newton meter. Then moment about the Z-axis would be, so this is about x-axis, is 80 forces constitute a couple about the x-axis. So this is about Z, this is about Z, and this is positive 150 Newton meter about Z. Your right thumb is pointing towards the Z-axis. So it is equal to 60 plus 150 equals 210 Newton meter. So in vector form, moment is 240I plus 150J plus 210K Newton meter. So that's it for this example. Then for our last example, 10.3, for the couple system shown in the accompanying figure, determine the magnitude and sense of the resultant couple applied at A. So this is a two-dimensional system, and we have the slopes. So this problem is best solved by resolving each force into a couple other than applying force times perpendicular distance. So let's apply Barigdon's theorem here, or let's resolve first the forces into couple. So for the horizontal component of this 300 here, we have a 30 Newton force rather, which which is a force of a 30 times something couple. And let's resolve that into its x and y components. The horizontal component here is rightward. This one is leftward. So 30 cosine 20 is equal to 28.19. So we have rightward and leftward. That's a couple. Then the vertical component, this is downward, and here it's upward. 30 sine 20 is equal to 10.26 Newton meter. For this 50 Newton force or forces which constitute a couple, and let's resolve this into components. The horizontal is 50 times 4 over 5 rightward here at D, then leftward at E. So 50 times 4 over 5, the hypotenuse is 5, is 40 newtons here. Then the vertical component, this is upward and this is downward. 50 times 3 over 5 is 30 newtons. So upward, then downward. So the couple therefore is, let's assume counterclockwise couple as positive. So let's begin with this 45 times 1.2 couple. So counterclockwise positive, so 45 times 1.2. So this is point A. Because these are all couples, so it doesn't, the moment center is anywhere. It may be at B, C, or it is independent. So the sense and magnitude of the couple are not affected by the choosing of the point. So it's the same. 45 times 1.2, then this 10.26 is counterclockwise, so 10.26 times distance 1.6, then 28.19 is clockwise, so minus 28.19 times 1.2. Then finally, minus 30 clockwise times 0.9 plus 1.2 is 2.1. These 240 Newton forces are collinear in action, therefore they are just in equilibrium. So this is the net moment or the resultant moment about A. And it is negative, so meaning our assumption that the resultant moment is counterclockwise is wrong. So let's correct it. Moment about A is 26.41 Newton meter and it is clockwise. So that's it for this lecture series. I hope that you can follow the solution, and if you're confused, then you may proceed to the principles first before going to this uh, lecture series. So I hope that it will help your studies in answering your assignments and problems where you want to gain expertise in statics. So goodbye and don't forget to subscribe.